Welcome, welcome you all to this lecture session of transportation problems. Since all of you know, we have shifted our general chalk duster mode of study into digital platform. So today we'll start with transportation problems. What do we mean by transportation problems and how it is done, how the problems are solved in a transportation problem, how does it look like. So this will be the our primary objectives. So this session and this subject will be divided into, we'll discuss this transportation thing into three steps: lecture 1, 2 and 3. In the first lecture, okay, let us describe it. So myself Arindam Mukherjee, I am currently working as an assistant professor of Dr. Sudhir Chandrashur Degree Engineering College, which is under the JS group. So let us move on to the next slide. See, what are the objectives? As I said earlier that uh, this session will be having basically three sessions. So it will be divided into three categories: 1, 2 and 3. So the first part will be discussing about how to solve the basic transportation problems to get the initial basic feasible solution, and we'll describe what actually transportation is, what is the importance of this problem, what are the applications of this problem in real life. Okay, so we'll be dealing with those things, then we'll move on to the solution of this initial basic feasible solutions. Okay, so this will be the topic of first lecture. In the second lecture we'll be dealing with some special cases like loop formation. So we'll be discussing what do you mean by loop formation, what is a degenerate basic feasible solution, and we'll deal with a basic method to find the optimum solution, which we call as Modi method. Okay, so in the lecture 3 we'll be solving some problems. We will be solving problems. Okay, so this is a basic characterization of the lectures which we'll undergo. So in the first lecture we'll deal with the concept of transportation problems. We'll try to find out the initial basic feasible solutions, and in the second and third lecture we'll deal with the optimality test method. Okay, so let us move on to the next part, which is the outcome. So as I said earlier, you will be able to understand the statement of transportation problem. You will be able to understand the transportation problem statements. You will be able to find out the initial basic feasible solutions. So there are some three methods we'll be discussing with that shortly. In a very short time we'll be discussing with these three methods how to find this initial basic feasible solution. In the second lecture we will be discussing about this loop formation and this degenerate basic feasible solution. So these two are included in the second lecture. Okay, and also this part will be involved in this second lecture. This part also will be involved in second lecture, and in the third lecture we will solve a combined problem. Actually, any transportation problem has to be solved in two different ways. Actually, first you have to find out the initial basic feasible solution, then you have to move on to the optimal test. So in the last lecture of this transportation series, we will deal with such problem where we will be solving the whole problem, and I hope that will help to understand the whole problem itself. Okay, so let us move on to the next slide. Okay, see what is transient. Suppose this is some supply point and this is some demand points. What do you mean by the supply point? Suppose it is a manufacturing unit. Manufacturing unit. So it can be some company which is producing some materials which needs to be delivered here. So this is the point one. This is the point one. So this is the point one of demand. So where this company has to deliver the materials which it is producing. Okay, so in a large industry, it can be within the industry itself, or for small industries, you may found that the materials are being transported from some other place also. So both the cases can coexist also. So let us deal with that. So let us consider there are, so as I was saying, so these are the supply points. That means where the product is being manufactured. So let us consider there are I number of supply points. I supply points. Okay. And there are J number of demand points. So that means there are I supply points and there are J demand points. Now, what are the condition? The condition is that each material can be transported from each supply point to each demand point. So like from point 1, from supply point 1, you can deliver the material here, you can deliver it here, you can also deliver it here, and you can also deliver it here. So that means from from each supply point you can, from each supply point to each demand point. So the material can be supplied or it can be transported from each of the supply points to each of the demand points. Now you can understand that transportation of this material will obviously involve some cost in it. So this is the cost, Cij. So what do we mean by this Cij? Cij, by Cij we mean that C stands for cost, I stands for the supply point, and J stands for the demand point. So when we are supplying the or transportation or transporting, so when we are transporting the material from supply point I to demand point J, it will invoke a cost of Cij. So that means C15. So what does it mean? From supply point 1 you are transporting the material to So C15 means that you can supply, the cost of transportation is C15 when when you are transporting the material from supply point 1 to demand point 5. Now let us consider you are transporting X15. So what is it? It is the quantity of material. It is the quantity of the material which is being transported. So when you are supplying a single unit of material, it is taking C15 amount of cost. If you transport X15 amount of material, then the total cost will be what? It will be very simple. You can think it off. It will be obviously X15 into C15. So you can understand now the total cost when you are supplying or transporting the materials from each of the point 1 to I to the demand points 1 to J. The total cost will be C I J X I J. So you can say that it starts from 1 to 1. You can say it starts from 1 to J. Sorry, it will be I. So starting from 1 up to I, starting from 1 up to J. So this is the total cost. So cost of what? Transportation. Transportation of how many material? How much material? Xij. So this Xij can change depending on the supply points and the what? And the demand points. That is very simple, I think. So this Ij depends on the number of supply points and the demand points. So obviously any company involved with it, what will be the objective of any company? Any industry will obviously try to minimize this cost. So if you remember the LP formulations, then our objective will be to minimize this Xij Cij. So this will be our objective. Okay, this is very simple. Now any LPP will have some constraint. There has to be some amount of equations depending on which they will be, this problem has to be solved. Now let us consider the total supply considering all the points, that means 1 plus 2 plus 3 up to I. So considering the total supply for the points 1 to I, let us consider the total supply or the availability is AI, and let us consider the demand is B. So let us give a summation over here, so which indicates the total supply or availability, and this represents the demand. So AI is nothing but the availability and BJ is nothing but the total demand. Okay, now see, if if the availability is not more than the demand, then this supply or the transportation of materials is not possible, it is not feasible. So you have to understand that this Xij, this is the amount of quantity, this is the amount or the quantity which is being transported. So this Xij will be less than equal to AI. That means
the quantity which is being transported must be less than that of the available quantity, and the quantity which is being transported will be must be greater than x must be greater than bj, summation of bj. So this is the basic formulation. So this is for all I, this is for all j. Okay, now, oh sorry, very sorry I am. Okay, now suppose that the company is transporting the material more than that of the demand. So the transportation does require some amount of cost. So what is the reason that they are not going to transport the material more than that of the demand? So we can say that it will be obviously equal to bj. Sorry, I am just forgetting the summation part for all j. Okay, so the amount of material which is being transported will be always equal to the summation of bj. So the company is not, it is ever, it is not ever going to transport more than that of the demand. Okay, now if you consider the availability, which was summation of ai, is exactly equal to the demand, then the problem changes little bit. Okay, so there was a less than equal to sign, and we have already considered that the company is not going to transport the material more than that of the demand. So there is a little bit of change here and here. So what will happen here? As ai, let us do it first here. Since xij is now equal to bj, and bj, summation of bj is equal to ai, we can say that xij is also equal to ai. So now this becomes an example of, considering this also, an example of balanced, okay, right, I'm very slow writing these things, balance transportation problem. So this is an example of balance transportation problem. So what do we mean by balance transportation problem? That supply is equal to demand. So for balanced transportation problem, the supply is equal to demand. But for unbalanced problem, there will be some differences between the supply and demand. The supply and demand are not going to be equal. But for balanced transportation problems, it is always equal. It is always equal. Okay. Sorry. So now we'll be discussing the objective of transportation problem. So this is the thing. You have to find the minimum cost. So this xij, cij, you have to minimize it. You have to minimize the summation of xij, cij, the multiplication of xij and cij by using some algorithms. So you are transporting a single commodity from a given number of sources to a given number of destinations, like the supply points and the demand point. So you are So you are transporting the material from some source points to some demand points, and your objective is to minimize the cost of this transportation by using some algorithms. This is the thing. This is the objective of any transportation problem. Okay, is it clear? So let us move on to the next slide. So this is an example. See, so this is the minimization part. J is equal to summation of what I am saying it earlier. It is written same thing. This AI is nothing but the demand. This BJ is not, sorry, AI is the supply, BJ is the demand. So when AI becomes equal to BJ, summation of AI becomes equal to summation of BJ, then we can say supply and demand are balanced. If the demand is equal to supply, then it is a balanced transportation problem. If the supply is more than demand, then it is an example of unbalanced transportation problem. Okay, so I hope you have understood the what do we mean by balanced problem and unbalanced problems. Okay, now here comes the most interesting part. How do you solve this transportation problem? Okay, now how does a transportation problem look like? Okay, I'm not trying to draw here, we'll see it in the next slide. So if you remember, I had said that initially we have to find a basic feasible solution. Then we go on to find the optimal solution. So there are number of feasible solutions, but amongst them we have to find the optimal solution where the cost of transportation becomes the minimum. This is the point. This is the most important thing which we have to understand. Now, how can we find the initial basic feasible solution? This is the first rule. North-west corner rule. Northwest corner rule. Okay, northwest corner rule. Next comes minimum cost method, or we sometimes we say matrix minima method. Okay, and the next one is penalty method. So this penalty method is very important. You have to understand it very clearly. There are some very important concepts regarding this VAM. It is sometimes called as Vogel's approximation method. Penalty method and Vogel's approximation method are all the same. So there are three methods: northwest corner rule, matrix minimum method, or which we call as minimum cost method, and the third one is the most important one, VAM. The most efficient of these three methods is VAM. This is the least efficient. It is somehow, it stands somehow in the middle position um, of its efficiency, and this is the most efficient one and most scientific one also. Okay, now after finding the initial basic feasible solution, see, we can, for a for the same problem we can find at least three solutions. Now obviously there is a high chance, there is a high probability that these three solutions are not going to be same. So among the three solutions which we are finding for a single problem, we have to understand and we have to surely say that this is the minimum cost. So until and unless we cannot say that this is the optimal cost, this is the optimum cost, or this is the minimum cost of transportation, our problem is not solved. Okay, so after finding the initial basic feasible solution, we have to move on to find the optimal solution. So this is a very important method: modified distribution method, MODI method, or UV method. You will see that we will be using some constraints called as UV. This is why it is called as UV method also. Okay, so we'll be now solving some problems, so trying to find out the initial basic feasible solutions using northwest corner rule, using the minimum cost method, or using the VAM or the penalty method. So let us move on to the next part. Let us move on to the problem which will be solving by the northwest corner rule. See, so this is what a transportation problem looks like. So there are sources. I hope it is visible to you. This is the sources. How many sources are there? One, two, three. How many destinations are there? One, two, three. So at source 1 the supply is 10 units, at source 2 the supply is 15 units, and at source 3 the supply is 40 units. At destination 1, so I think you can find an analogy between the supply demand points and the sources destination points. These sources points are nothing but the supply points, and and these destination points are nothing but the demand points. Okay, see, the summation of this total supply available in these three source points is 10 plus 15, 25. It becomes 65. And now see what are the demands. 20 plus 15 plus 35 plus plus it also becomes 65. So now we can see that total supply is equal to total demand. This indicates that this is a balanced this is a balanced transportation problem. Okay, so I hope you can understand it now. This is an example of balanced transportation problem where the total supply becomes equal to the total demand. Now we'll be observing how to solve these problems using the northwest corner rule. So let us just help me uh, let us just write all these problems. Mm, I'm just rewriting it. Sorry, I have done one more here. So let's just cover it up here. Okay, see, so these are the S1, S2, S3. This is D1, 1, 2, 3, D2, D3. So we have just seen that it is an example of what? Balance transportation problem. Now 2, 2, 3, 4, Sorry, I have done a mistake here. Okay, let's just write 2 here. 2, 2, 3, 4, 1 and 2. 1, 3, 1. Okay, so this is 10, this is 15, this is 40, this is what, 20, 15, and this is 30. Okay, now comes the most important part. See, this is our graph. Let us just consider this part only. Okay, so for this graph, this one this one is the northwest corner. This is the northwest corner of this matrix. So what we do, we we allocate some amount here. Now how much we can allocate here? See, it has a supply of 10 units. So the maximum we can allocate is 10. We cannot allocate more than that. So sorry, so the maximum I can allocate is 10. Now when I have just allocated this amount of 10 here, it means the supply gets reduced to 0, but the demand is also getting reduced. 10 10 demand 10 amount of demand has been being supplied by this point, so there is still 10 demand, but it means that this row is exhausted. So we just give a line which indicates that this row has been exhausted. Now after this is completed, the matrix looks like this. It is the part which remains after the allocation of 10. Now for this one, let us do it by a different color. I hope it will help you to understand. So this is the point I am trying to make. So this is the matrix. Okay, now for this matrix, this is the northwest corner. This point is the northeast corner. This point is the northeast corner. So what we do, we can see that there is a demand of 10 and there is a supply of 15. So that means we can give this 10 here, so that this demand is completed. So what we do, we just draw a line which indicates that this row has been exhausted. This row has been exhausted. So now the matrix looks like this. This part is left now. I'm very sorry. This, after allocating this 10, the supply will also get reduced to 5 because you are allocating 10 from it. So the supply will get reduced to 5 and the new matrix looks like this, and the new matrix looks like this. Now you can allocate 5 only here because the supply is only 5 here. So what do you do? Why we are allocating here? Because for this matrix, the northwest corner is this point in this cell, the northeast corner. so we allocate 5 here. So this becomes 0 and this becomes 10. And now you can see that this has been completed. Now the matrix, only this part of the matrix is remaining, and we have, I'm very sorry, we can't just allocate here. It, actually this cannot be done. This 10 is still remaining, so this row is exhausted. So what, this is the remaining part. I'm very sorry, please concentrate. This is the remaining part. Okay, so the demand is 10 here, and we can see that there is a 30 amount of supply. So after that only one cell is left where we can allocate 30, which means it becomes 0. Obviously it has become 0, this becomes 0. So now the supply and the balance has been balanced. So the supply and the demand has been balanced. I'm very sorry, pardon me. Okay, so now see this 2. What is this 2? This is the cost of transportation of a single unit of material from supply point 1 or the source point 1 to the destination point 1. Now how many, how much you are going to transport here? You are going to transport 10 units. So the total cost, now we are dealing with the total cost, 2 into 10, just give a bracket. So we are doing the total cost, 2 into 10. See, in the next part we have allocated 10 units of the quantity, and the cost is, the cost of transportation for a single unit is 4. So you are going to transport 10 units. The total cost will be 4 into 10. It is very easy. It is school level mathematics. In fact, it is class 5. A 5 standard student can easily understand what is going on here. So 10 into 1, I'm sorry, it was 3, I misread it. So it will be 3 plus 30 into 1. So now we'll just add up the total cost. So the total cost is 20, 40, 65, 95 and 30. So it becomes 125. So the transportation of these materials using the north west corner rule will give us a cost of 125 rupees. So this is how you solve it. So first you identify the northwest corner. You just identify, suppose, see, for this problem, this is the first northwest corner. Since you are allocating the whole 10 here, this row gets exhausted, this becomes 10. Now you have this part of the matrix left. For this matrix, this is the northwest corner, you allocate 10 here, this 15 gets reduced to 5, and this is exhausted, so this becomes also 0. Then you have this part of the matrix whose northwest corner is this. You have only 5 demand here, sorry, 15 here, but you have supply of 5 units, so you can only allocate 5, which keeps the 10 unit left. So the demand is not completed here, but this row, that means the supply, has been exhausted. Now this is the part which is left, so now you have to allocate 10 here. So I hope that you have easily understood what is how do you find the initial basic feasible cost using the northwest corner rule? So find the northwest you just find the northwest corners and go on allocating. But for sorry for matrix minima method, it is not as simple. Okay, it is not as simple as it was earlier. Now for this problem, here you have to remember this thing. You have to just concentrate or focus on this word, this minimum cost method. Since these numbers indicate the cost of transportation of a single unit from a certain source point to a certain demand point, like 2 is the cost of transportation for a single unit material from source point 1 to demand point 1. So now you have to find out the minimum cost from all this. Now you can easily find that there are three ones. So now you must be confused where to allocate between these three ones. So let me tell you that don't worry, you can allocate wherever you want, but the common sense must have the common sense. Okay, see here the sub the demand is 30 and here you have a supply of 40. So what will be your objective? You will obviously try to allocate most amount the most of the amount should be allocated in such a way so that the cost is very less. So what we'll do, we can allocate this 30 here, we can allocate this 30. Oh, let me do this problem here. This is a very good software, I must say. Sorry. Very sorry. I'm very poor at these things, okay? So please bear with me. I request you to bear with me. Still, I know I haven't justified the time I have taken here. Okay, so let us deal with it. So this is 2. Now I have a lot of space here. 2, 4, 1, 2, 1, 3, 1. So 10, 15, 40, 30, 15, 20. So 1, 2, 3, 1, 2. Okay. So as I told you earlier that this is the minimum point, this is the minimum one, and this is the minimum one. So here you can allocate the maximum of 20. So initially you have to find out the minimum cost from all the numbers given over here, and then you start allocating. Now using what I said earlier, so you can allocate 15 here. You have to apply some common sense. Okay, you can allocate 20, but you can allocate 30. So what will you do? You'll obviously try to minimize the cost. Your objective is to minimize the cost. What do? You allocate 30, which makes which exhaust which helps to exhaust this row. The demands is completed, but the supply is still there, and it is 10. Okay, so now we will be dealing with this part only. We'll be dealing with this part only because this column has been exhausted. We don't need to worry about this. So between these materials, you can see that there are two ones. So obviously you will allocate here. Now you can allocate 15 here. If you allocate 15 here, then it will be 0. This column will be exhausted, and this row, you can give us this sign here to indicate that this row has been also exhausted. Okay, now here we'll allocate 10. So you can see that when I had allocated 15 over here, the cost remaining was 2, 2 and 1. So I had the provision, I had the chance to allocate 10 here. Okay, so after allocating this 10, this supply is reduced to 0 and this demand is reduced to 10. Okay, now this is the only cell left, so I have to allocate 10 here. There is no option, so this demand is completed, and there is a supply of 10 units, so you can fulfill this demand. So now what are the solutions I have received? I have found this cell, this cell. I'm just writing down the allocations here. So how many allocations are there? There are 4 allocations. 1, 2, 3, 4. So 10 plus 10 becomes 20, 15 is 15, no problem with that. 30 is, so all these allocations are completed, and it also relates to the supply demand characteristics. So as I was dealing with the same problem, so I didn't made the calculations. But whenever you are solving a problem, you have to first see that the total supply is is getting equal with the total demand. If the total supply is equal to total demand, then we can say that it is a balanced transportation problem. Then only we can apply these algorithms. We can apply northwest corner rule, we can apply matrix minimum method, we can apply VAM, whatever. But we have to apply this for a balanced transportation problem. But for unbalanced transportation problem, this is not so easy. We have to first make it somehow balanced, then we can apply these algorithms. Okay, so let us do the important part, the total calculations. So what will be the total calculation? See, it will be 20, 2 into 10. Okay, I'm not repeating what does this 2 means here. Plus 15 plus 10 plus 30. So 20 plus 15 plus 10, so it becomes 75. If you remember, for northwest corner rule, it was 125. For matrix minima method, it has been reduced to 75. So which one is left? Most which method are you going to apply? Obviously this matrix minima, but you don't know this is the feasible, this is the optimum solution or not. Until and unless you don't know that this is the optimum solution, you cannot say this is a minimum cost. So we'll be dealing with the same problem again, but we'll be solving using the VAM method. Okay, so we'll be dealing with the VAM method next. This is a very easy problem, I must say. Okay, sorry. Okay, so we are dealing with VM problem now. Now see that we have written a word over here, penalty method. Now what does this penalty means? Suppose you have no other way to allocate some 10 quantity here, but if you are allowed to allocate this 10 here, how much would you have saved? You have saved rupees 3 for per each quantity of the material which is being transported. So in total you would have saved 30 rupees. So penalty is that thing. Okay, actually I have used 1 and 4. If we use this example, if we allocate, if we are compelled, we have no other way to allocate this 10 here, then for each unit of transportation we would have lost 1 rupees. For the transportation of 10 units we would have lost total 10 rupees. Okay, so penalty is that cost, the extra cost which you have to give because of this allocation, when you have no other way to allocate in the maximum cost, in the cell where the maximum cost is present. Okay, so it mathematically means that you have to just find out the maximum number in present certain row, and I'm very sorry, let me repeat once. You have to find the minimum number present in the row. See, for this, let us clear it. Okay, so initially at the first you have to find out the minimum number present in a row. So for this row, 1 is the minimum number and 2 is the next minimum number. So the mathematical difference between this 1 and 2 is what we mean by penalty. The mathematical interpretation of penalty is that the difference between the what we say uh, second mean number second mean number minus the first mean number. Okay, like 2 here and 1 here. So 1 is the minimum number and 2 is the next minimum number. So penalty here will be 1. So for this row the penalty will be 1. Now what happens when there is a tie? That means there are two similar numbers. So here penalty will be 0. Why? Because if you don't have any other way to allocate here, then what you will do, you will shift it here. So at the end, ultimately you are not going to lose here some amount of cost, because you have the option of transporting the quantity at same cost, but from different source point to different destination point, or we can say for the same source point to different destination. So when you are transporting some material from the same source point to the different destination point with the same cost, you mean that means that there is no extra burden of cost which is being suffered by the industry. You have a chance to allocate it in the next sale where the transportation cost um, for the unit material is same. So here the penalty will be 0. Okay, so similarly penalty will be 0 here also. Okay, now so we have to calculate the penalty for each row and each column. Okay, so we'll be observing now. I am getting better, you must say. Okay, so it is 1, it is 2, and it is 3. 1, 2, 3. So let us use this color here. 2, 2, sorry, 2, 3, 4, 1, 2, 1, 3, 1. Just writing down the demands. It is 20, it is 15, it is 30. Let us write down the supplies. 10, 15, and this is 40. So see that the total supply is how much? It is 10 plus 15, 25 plus 40, 65. 20 plus 15 plus 30. It is also equals to the sum of the demands equals to 65. So it means that we are dealing with a balanced transportation problem. Now we have to calculate the penalties. We have to calculate these penalties both row wise and column wise. Okay. Mm, very sorry, I must say, very sorry. So this is the matrix. Now we have to calculate the penalties. Now for this row, this is the minimum number 2, and the next minimum number is also 2, so the penalty becomes 0. For this row the penalty is 1, and for this row the penalty will be also 0. So this is the penalties row wise. Okay, and now we have to write down penalties column wise. See what is the penalty here? It will be 1 because 2 minus 1, 1, 1, 2. The penalty will be 1 here. 1, 2. The penalty will be also 1 here. Now, what is the importance of this penalty? Now, we have to find out where the penalty is the most. That means that is the maximum extra cost we have to use. Penalty signifies that the maximum penalty signifies that it is the point where we are incurring. Penalty signifies Maximum penalty signifies the maximum loss. So where the penalty is the maximum, that means the allocation has to start from there. Now here we can see the penalties are only 1 and 0. So we can start wherever we want. Obviously for this 1 points, because we know 1 is greater than 0. So again, using the basic common sense, we apply, we allocate 30 here, which makes this demand 0, and this supply is also reduced to 10. And what happens here? This, the demand of this column is exhaust. So we don't need to worry about this. Now after this calculation for this column has been completed, what we want to do, what we have to do is to rewrite the penalties again. See, let us see if there is a change in the penalties. Now this is the matrix we are concerned with. So row wise it will be 0, so there is no need to change. But here there must be a change, and it will be 3. So the penalty changes to 3 here, and this one should also change, and it will be 2. This will be 2. Now let us see if there is some change in the column wise penalty. Always remember that there will be no change in the column wise penalty. See that here, actually this is a general rule. Since you are not allocating in this row, so the column wise penalty are not going to change. So it will remain 1, it will remain 1. Let's just cut this penalty because it is already allocated, so there is no need to write this 0 here. Okay, so this has the maximum penalty. Now we have two cells. In this cell the cost is 1 per unit. In this cell the cost is 4 per unit. So what we'll do, we will allocate this 15 here, so that this, sorry, I'm very sorry again, this this row is exhausted, and let us give a cross here, so that this is also exhausted, and this, there is no requirement of this penalty. Okay, so we are done with these two columns. Now there is only two cells left. So in this case you cannot calculate penalty. So what you will do, you have 10 supply here, so just allocate 10 here. The demand reduces to 10. Here you have supply of 10, so you just allocate 10 here, and the demand reduces to 0. So now we have completed the allocation. So the total cost is 20 plus, for 10 plus 15 plus 30. So the total cost becomes 20 plus 30, so it becomes 75. So you can see that the cost of transportation using penalty method or VM method becomes 75. It was 125 in Northwest. It was 75 in matrix Minima method, and it is 75 in VM method. Let's just remember these three numbers because we will be deducting some informations from these results, okay, afterwards. See that whenever you are going to solve a problem, always my suggestion is that you just use this VM method, so that while optimizing this problem your efforts just gets reduced. Because whenever you are using northwest corner, this is easy, this is very easy, but it will give you trouble why when you are going to optimize it. Similar logic is applied for matrix Minima method also. It is quite simple, but when you are going to optimize the problem, the you will facing some troubles. The number of steps involved in optimizing will increase whenever you are going to use these uh, matrix Minima method or northwest corner rule. So my suggestion is that to find the initial basic feasible solution, always use this penalty method. Okay, I hope that you have understood all the methods to find the initial basic feasible solution. Okay, so we will end this lecture here. So for a little bit of recapitulation, whenever the total supply is equal to the total demand, we can say that it is a balanced transportation problem. In balanced transportation problem, you can find the initial basic feasible solution by three methods: northwest corner rule, by matrix Minima method, by VM method, or the penalty method. So my suggestion is to use VM method whenever you're trying to find out the initial basic feasible solution. Okay, so wait for the next lecture. I hope it will be interesting as it was. In the next lecture we'll be discussing about loop formation. What do we mean by loop, and what is the problem of loop formation? Then we'll move on to degenerate basic feasible solution. Okay, so this is the objectives of the next class. So hope that you are understanding all the things which I'm trying to convey, and I hope these lectures are helping you. If you want to comment, if you want to ask any question, please mail me at my mail ID, that is arhan1990 @gmail.com. Now the students who know me personally, I have two different mail IDs also. You can mail me there, and you know my WhatsApp number, you can easily call me. So let's hope for the best. Let's wait for the next lecture where we'll be discussing the loop formation and the degenerate basic feasible solutions. So goodbye, stay safe, and keep studying.